All right, how's it going, Global Hack Week? Let me know if you're in the room with me. I know some of you are still getting through the ad block, but we are keeping things rolling here. Yeah, let's go learn some MongoDB. I was muted. I am unmuted now. Hopefully, y'all hear my voice at home. Remember, folks, go ahead and register and check in at the link that is rolling across the bottom of the screen here. We're going to jump right into it in a moment, but let me go ahead and type this link out for y'all so you can go ahead and get registered and checked in. Alrighty. Let me know where y'all are joining from. Let me know if you're in the room with me. It looks like we still have some folks that are rearing to get in, maybe getting through that ad block from the previous workshop, but nonetheless, we are here and we are ready to go. Okay, let's jump right into it. All right, folks, welcome to MongoDB 101. My name is Rosendo. I do customer success at Major League Hacking. And whether you're new to databases, never used them before, maybe you've used a previous database and you're new to MongoDB, or maybe you're a MongoDB expert and you just want to hear my voice as I narrate through some of this amazing data and information that I'm about to provide for you. I promise, hand over my heart, that you are going to enjoy today's session. Right now, what we want to do is we want to help you feel comfortable using MongoDB and truly understanding exactly what MongoDB is through explanations and demos of some of its features and the capabilities possible within the platform. So before we get into all of that good stuff, I'm just going to go over our agenda for today. We've got an hour together and we're going to learn a lot. So the first thing we're going to do is we're going to have an intro to MongoDB and the document model. Then we're going to go over some important data modeling and schema design. Next, we'll give an overview of the query language and the aggregation pipeline. After that, we're going to touch on the data developer platform, and then we're going to cap it off with some Q&A. So if y'all have any questions, please drop them in the chat. Let me know. We've got a little bit of time today, and I'm seeing that folks are joining us from all over the world. I love to see it. Canada, Malaysia, Kenya, India, Sri Lanka. Oh, wow. Truly a global hack week, as I mentioned in the previous workshop, but I'm glad you're here with us today. Now that we've got the overview out of the way, I know all of you have heard of MongoDB before, but let's really take a second to dive into why the platform is so unique, especially for hackers like you, and why you'd want to maybe move over from the current database that you're using to a document database. So once again, if you're familiar with databases, you may have worked with the relational databases in the past, something like SQL, maybe like Postgres. MongoDB is a little bit different, and I'm going to explain all of those differences to you and some of the cool things that you can do with MongoDB as opposed to some of the other services that you may be accustomed to. All right, so MongoDB really is an intelligent operational data platform. So because of this, it can truly transform the way that you manage and interact with your data. It's the best way to work with data because it has a flexible document model, which I'm going to explain more about a little bit later. Within the document model, you can really store your data in a way that naturally fits your application without requiring a rigid schema design. So we're going to go over the differences between the relational database schema design and also the MongoDB schema design. And it's, I hope that it will be enlightening to everyone on the call. So the second reason is maybe not as relevant to hackathon projects or folks that are working in Global Hack Week, but when you get later in your careers and you're starting to make big decisions about data architecture within a professional setting, MongoDB also enables you to intelligently put your data exactly where you want it. So it's going to be applicable to you today, but also in the long run, learning about MongoDB is really going to be beneficial in your careers, because at the end of the day, when you're deploying, whether you're going to be deploying to the cloud or whether you have an on-prem server or a server that's basically physically located at the location that you're at, or maybe a combination of the two, the distributed architecture really does make sure your data is always available and close to your application. And the great part about that is the intelligent data placement helps to reduce latency. It improves performance for everyone using your application, and it grows as you grow, as you scale up your application and start to onboard new users in different types of data sources. Lastly, MongoDB gives you the freedom to run anywhere you like. So they support a wide range of deployment options, from fully managed cloud services to self-hosted solutions. So this increased flexibility really ensures that you get to choose the best environment for your needs, and it means you can easily scale up your application as it grows, as I mentioned before. All right, So one of the really great key advantages of MongoDB is its ability to run in a wide variety of environments. So this makes it really flexible. It doesn't matter where you choose to run your application, since you'll benefit from the same code base, the same APIs, the same tools and integrations that will give you a consistent experience across the board. So once again, if you're working on a hackathon project and maybe you have several different types of services and different places that you're intaking data from, MongoDB is going to help you to kind of normalize that data on the back end and be able to give you a consistent experience when you're querying that data across all of those different intakes. So it also has some unique features like search and online archives. With the MongoDB platform, you don't really have to worry about any compatibility issues because it really plugs in with any of the SDKs that you're going to be working with. Really popular ones like Python and JavaScript. I'm going to show you some examples of that a little bit later. But with all of this in mind, let's go over some of the crucial terminology, since I know some of you may be familiar with relational databases, but not super familiar with the way non-relational databases, particularly MongoDB, sort of label the content that goes into the databases. Really quick, before I jump into the slide, I do have some questions here. Is there any way to check in? Yeah, so you're going to go ahead and check into the link that I dropped in chat earlier. Oh, pardon me, it is the wrong link. We're going to go ahead and register. We're going to put this link up. So it's going to be GHWBW825 MongoDB workshop. So yeah, go ahead and get checked in there. It's going to be that link, and I put it in the chat earlier. So if you have any other questions, please let me know. All right, awesome. Thank you so much. It looks like we've got somebody taking notes here. I appreciate you. Thank you so much. Another question we've got from Horizon: is there an SQL equivalent that also has the same code base APIs regardless of where you are intaking from? I am actually not too sure, to be quite honest. I mean, you can go and search for some. I'm sure that you could find like, SQL equivalents, or maybe like other SQL databases that have maybe a flair of SQL but are slightly distributed, like CockroachDB, for instance, or maybe DataStax Astra. You could take a look at that yourselves and kind of do a little bit more research. And if you come up with anything, drop it in chat, and I'm happy to discuss at a later point in time. All right, so jumping right into the slide, some of the terminology that we have. So the first things first, you're going to look at collection versus table. So in MongoDB, we use the term collection rather than table to refer to a grouping of documents. So collections store multiple documents, just like tables would in a relational database store multiple rows. The next is going to be document versus row. So instead of rows, we're going to use the term document. Each document is just a record inside of a collection, and it's just like rows. Basically, all of the every single line of data that you put into your document is going to be referred to as a row. Second, we're going to have the field versus column. So in each document, we have fields, which can be thought of as columns in a table. So each field represents the properties of the data being stored. So if you want to think of it from a kind of spreadsheet sort of perspective, the document is going to be the row across, and then the field is going to be the data label for each of those, for each column that you have within the document. So it's like first name, last name, email address. Those would all be considered fields. Next, we're going to have embedding, linking $lookup versus parent-child tables and joins. So this is a little bit more complicated, but in relational databases, you're going to have a parent-child table, and you're going to be using joins to sort of query data that lives across different types of tables within your database. Whereas in MongoDB, they offer a more flexible approach with embedding. So this means you can actually store related data within a single document without having to spin up an entirely new document or an entirely new table. And basically the reason that's so performant is because adding additional tables to your database could kind of make things a little bit messy, whereas with MongoDB, you could just start adding things to the same table that you had related data. The other thing is MongoDB has linking. So this is basically storing references to related documents, and the $lookup operation allows you to join that data from different collections. So it's really basically easy to see all of your data in one place versus having to kind of look for it across a lot of distributed places across your database. So if you're coming from a relational background, these concepts may be a little bit familiar, but just packaged a little different. It's essentially the same thing with just a little, a couple of caveats here and there. So now that we've got that out of the way, let's go ahead and take a deeper look at our document model. And let's see here. Do we have any questions? Any prereq installations to be done? There are no prereq installations. I am going to be sharing some links with. I am going to be sharing some links with you throughout the workshop that you can go and check out on your own. But you're not going to have to install anything. Basically, great examples of like how MongoDB actually works in real life. Let's see here. Supabase could be one of the relevant alternatives for MongoDB, but use SQL. That's really interesting. I will dive into that after this workshop, and I will let you know in Discord if you want to check us out on Discord and continue the conversation there. Hey, I am new to this. Hey, I am new to this. Do we also learn some beginner stuff in this stream, or do we need some prerequisites? This is going to be a very beginner friendly workshop. It's essentially explaining all of the fundamentals that you need to know to get started with MongoDB. Hence the name MongoDB 101. So definitely stick around. If anything gets too confusing or too convoluted for you, drop it in chat and I will try to slow things down and kind of explain some of the concepts that you're not getting in a little bit more detail. And lastly, is MongoDB good for persisting pictures? Yes, absolutely. It's good for all of those things. You're going to be able to store all of that data there. And there are also other tools. And actually, you'll see those in the live examples that I'll be showing a little bit later. So no worries there. It's definitely an excellent tool for persisting pictures, videos, and websites. All right. So back to the document model. At its core, MongoDB's document model is truly built around the most intuitive way developers think about data. So think about how you would structure data in your mind. MongoDB's document model sort of captures that in a object form. The great part about this document model is that it's inherently flexible while allowing any necessary data governance. So it's as strict as it needs to be, but not so strict that you can't add new things to it or you can't change it on the fly. So you can really start with a super basic structure, like just the first name, the last name, and the email, and then you can evolve your data needs as your application begins to like basically utilize different types of information and data. So the model's versatility makes it particularly powerful as well. So from this diagram, you can see that whether you're storing simple key value pairs, nested objects, graphs, there's even time series data there and geospatial information, all of it fits naturally into the same document structure. So what does this mean for you as the hacker? This means that you can model both structured and semi-structured data without having to do data gymnastics to force everything into rigid tables or super complex schemas, as I've kind of alluded to that throughout the presentation thus far. So if you take this example with information about the matrix, we have a bunch of basic metadata saved, such as our ID field. You're going to see the title there and a bunch of other things. But we also have a nested tomatoes object with all of the reviews that are coming in about the movie or the title that we have listed there. So the reason this is interesting is because you will probably have the movie object stored into your database when the movie comes out, but no one's seen it yet. So how do you incorporate the reviews within the same object after the movie comes out and those reviews start pouring in? If you had a relational database, you would need to spin up an entirely new table and then start intaking that data into that table. Whereas with MongoDB, you can dynamically take in the reviews for that specific movie and then add it to the original document that you had already made. So that's that's one of the use cases. Someone in the chat is asking about some of the use cases that MongoDB is best for. Like I said, if you have an application that you know is going to be evolving over time, MongoDB is really going to be the most performant way to intake that data as it evolves. All of this information is really nicely represented in a single coherent document, and it's both human readable and queryable. So really, like I said, it's just a lot simpler, especially if you don't know exactly what your application is going to do at the beginning. Let's say you're at a hackathon and you're going to decide like what type of application you want to build, but you know it's going to need a database. You can start with a MongoDB database that has a really simple structure, and then as your idea evolves, you can start adding new fields to the documents that you're going to be uploading, and it's just going to be, like I said, a lot more flexible for you instead of having to go back and sort of edit everything. And I'll get into some of the other reasons why it's super performant in that manner. So here we're going to compare and contrast the relational database versus the actual non-relational database, which is MongoDB. So if you take away one piece of information from this workshop, I want it to be that data that will be accessed together should be stored together. So what I mean by this is, simply put, related data should be stored together for a lot of key benefits, such as improved performance, simplified data modeling, scalability, simplified querying, a lot of different things that will be basically beneficial for you as the hacker as you're starting to build out your database. The idea is pretty different from relational databases because you often have data that's spread across multiple tables. So let's take a look at the document on the screen on the right-hand side. The first thing I'm going to notice about this is that it's self-describing. Each document contains both the data and the structure, making it pretty easy to understand the data model at a high level. We don't have to look at an external schema to try to understand the data. We understand this is John Doe. We understand where he works, the street, the location, the geolocation of the address that's provided, along with like the date of birth and phone number. All of this stuff is related to John Doe and the information that he has provided to the database. So as we went over in the previous slide, documents are inherently intuitive in this way because they represent the way people think. When you look at this document, you're just going to see all of the related data together in one place, kind of like the way you would mentally group that information in your mind. Now let's jump over to the left side of the slide. Take a look at the relational model. The data for the customer is actually split across multiple tables. So to understand the complete picture that we're trying to create, you need to actually join these tables. This process is going to be complex and it's not directly intuitive without knowing which queries are used in the application. Let's say you're working in data science, or like you're a data engineer, and someone from your team asks you, hey, get me every user in our database, get me their location where they work, the address to that location, and the geospatial information that's involved, as well as the phone number, and also their date of birth. In order to find all of that information, you're going to have to go to all of the different tables that contain all of those little bits of information, and then create a very complex query that joins all of those databases in order to come up with the more simplified version that you see on the right. So as I mentioned before, it's just going to be a little bit easier for you in the long run to get set up and to then once again utilize your database. So Horizon asks, this whole document is considered one record. So yeah, on the side, this document is basically going to be, yeah, it's just one record within the document and has all the different fields as I mentioned before. If you want, we could kind of jump back to one of the previous slides, and it's going to be this one. Yeah, so you have the database. This document is going to be within a single collection, and within that single collection, you're going to have, like I said, all of the different documents that have that information that we showed in the slide that I was just at. And I think it's going to be this one. Yes. So yeah, all of that is going to be within the same collection, which is pretty interesting. And like I said, it's going to just be a lot easier for you to query moving forward. So is there a lot of repetition in the right side for headings? I wouldn't say there's a lot of repetition at all, actually. I mean, yes, you have the address, and then obviously the address has a nested key pair value with another object within it that actually has the physical address. Maybe the naming convention could have been done a little bit different, but it isn't as repetitive as like basically having to go in and jump around from one database to another. I think it's probably just a what's it called, a naming convention thing. All right, so moving forward. So we've talked about how intuitive the data model is. Let's explore how versatile it is. So documents can represent any structure of data model, so it provides incredible flexibility. At the core of MongoDB, it uses JSON-like objects, which I think a lot of folks on the call are probably already familiar with. And you can embed arrays, subdocuments to represent complex data, and you could also model flat and tabular data. So for simpler data models, MongoDB supports straightforward key value pairs. MongoDB can also handle really rich text data and can also represent complex relationships and hierarchies using graphs with nodes and edges. So what this means is that MongoDB can accommodate even the most intricate data structures. Someone asked earlier about persisting pictures, images, things like that. MongoDB is fully equipped to handle any type of data type that you want to put into it, and it's going to be able to do so in a more flexible way. So to further boost developer productivity, you can access documents through native language drivers or idiomatic native language drivers, which means you can actually query the database in a way that is more intuitive to the way that you speak. So instead of saying like select all in database in this database, in this table, etc., it's more like grab me all of the users from like this collection and make sure that they're all within these 2 ages. And it's a little bit more intuitive in that sense, and it supports a ton of different languages, 40 different languages in fact, and separate. And basically, it allows you to do all of this within whatever APIs you're using for the many SDKs that are currently supported. So documents are just natural in the way you model your data and the way that you query it. So let me quickly explain what I mean by flexibility. In a traditional relational database, in order to add a new field or column to an existing table, such as a phone number, you would typically require an alter table statement, schema modifications, and even potential application downtime. With MongoDB's document model, you can actually incorporate any of these changes seamlessly. So if you take a look at this example on the slide, it's kind of going to walk you through some of the things that I've already spoken about. We have information about John Doe, but let's say we wanted to add the phone contact information, we can simply add a new field dynamically at runtime. So this means there's no schema migrations, there's no downtime for your application, and there's no complex or extra statements. You could simply add the phone number to the existing document. The document on the left, obviously the original, whereas on the right, we have the phone number integrated. So ask yourself, why is this so important? I've kind of been harping on it this entire time, but let's consider an application where your requirements are evolving very rapidly, such as applications that incorporate real-time data. In those cases, it becomes crucial to really move quickly without being constrained by a rigid schema and possibly having to take your application offline as you remodel that database. So really, it just makes your application a lot more available for a prolonged period of time. All right, so we're going to dive into an actual live example, but before we do that, let me take a look at some of the questions here. I feel like I've answered this one. In what situation is relational database better, or is MongoDB? Oh, so okay, so for institutions that require more rigid and sort of strict data guidelines, like think of like financial information or maybe even like medical information, a more rigid schema or a more like rigid and strict database, like a relational database, might be better, because while both are ACID compliant, you're probably going to need a little bit like more strict data governance with information like that. So I think a lot of like government agencies and financial institutions still rely on relational databases. But for folks that are coming in and trying to maybe start their own like startup or like create an application at a hackathon, some of that data governance is not as necessary, especially if you're just starting out. So that's why I think like MongoDB might be a little bit more relevant to the use cases that you all encounter on a day-to-day basis. Peculiar Frost, I love that name. It's sort of like you want related data, like information on a person specifically, then you need MongoDB. But if we need data like people from Canada or people from India, like names only where in Canada they are from, I kind of get it. What I'm going to say here is that you can use MongoDB for both use cases that you're stating here. It's just a matter of whether or not you want your database to be more flexible in the long term, or whether you want your data to be more rigid and more what's it called? Just I guess more compliant to whatever regulations you're trying to comply with. Be a little bit more rigid, just for I guess like posterity's sake. And looks like we've got an answer here. I'm going to jump to the next one. So MongoDB is just like a more intuitive JSON way of storing data that we can modify. Yes, absolutely. That's exactly what we're trying to get at here. And I'm going to show y'all this really cool example. So we had the folks from MongoDB actually come in and, they built out some pretty cool example applications. This one's called MongoMP. And I'm going to drop the link in chat for y'all. Let me just go ahead and drop it in chat, copy and paste here. You can jump into this and actually take a look at it yourself. So this is like basically a Spotify clone that you can use on your own. And let me get that link up and running here. And all right, actually this is too big, but we'll take a look at it later. So basically, what this does is it allows you to kind of search through some of the songs. These are all AI generated songs, so there's no copyright infringement here. But you can see, like, like it stores all of this data. Someone was asking about images. This stores actual data, actual audio files as well. So obviously, MongoDB is pretty good at doing that. I'm going to show you how the data sort of comes in when you go in and log in. So I'm going to go ahead and create a rosendo@ghw.com, and I'm going to make a password. So I'm going to go ahead and log in. Oh, check your credentials and try again. Oh, I got to register. Sorry about that. Cool. So my name is Rosendo from MLH. I'm going to say GHW. I think I used the MLH one, and then I'm going to do rosendo@ghw.com. And then my password is going to be a simple password, but we're going to get registered. All right. Now we're going to get logged in, rosendo@ghw.com, and then we're going to put in our password. So now we're going to have now we're going to have all of this stuff related to my current account, and all of the things that are currently within the database are going to be reflected in MongoDB Compass. So let's jump into our MongoMP instance. So the other thing I did want to let y'all know is you can use MongoDB Compass to kind of go in and search some of the cool things that are in your database. So as you can see here, we've got all of these different collections. We've got artists, playlists, songs, and users. And within each of these collections, you're going to see some documents. So it's going to take a little while to fetch. So bear with me while I do that. And you're going to see that all of these are documents that are representing the users. And you're going to see, and we got some folks already signed up. Shout out to Namish. If you don't want your email up, I'm going to go ahead and scroll up a little bit, but you can see here that this is the object that I just put in there, Rosendo from GHW. It's got my email nested in there, and it's got my password sort of extricated from public view and represented by this hash. And then you have the created at and the updated at. And the other thing I do want to show you here, which is pretty interesting, is once you start making an actual playlist, you're going to jump into the library here. And I'm going to create a playlist, and I'm going to call this Rosendo's GHW playlist. Let's go ahead and create it. And I'm going to go ahead and start adding some songs to this playlist here as this loads up. I like the looks of these ones here, and they're also very easy for me to access because they are clearly at the top of the page here. So I'm going to go ahead and add 5 of these songs. And once that's done, I'm going to scroll up. I'm going to go back to the library, and you're going to see this should populate in a moment. But let me just make sure. I may not have clicked it correctly. Pardon me, folks. Yes, I got to click this. Add. So we'll do 4 because I'm lazy and I don't want to go to the next one. All right. So now you can see here, we've got 4 different songs added to our playlist. And the cool thing about this application is as you're actually going through it, there are like little information bars that you could use. And sorry if that's so loud. There are little information bars that you can use while things go on. And it kind of shows you some of the information that is related to the queries or maybe even the backend functionality of some of the stuff that you're doing. So here, if you click on search, you're going to see that this is how it actually queries some of this information. So this is a really good learning tool if you want to kind of see how queries are structured within MongoDB. So definitely take your time to kind of search through it yourself. And let me just scroll back up into library, and you're going to see that my playlist is populated. Let's jump back into MongoDB Compass to kind of take a look at the playlist. So we should see a playlist that actually represents the playlist here. So as you can see, it's Rosendo's GHW playlist, and it's got the songs listed here as well. And we're going to go into some of the I guess like the schema and the data, some of the data modeling that goes into how this data is structured once you do actually get into the database. Alrighty, so let's jump back into our workshop here. Answer some questions. So is MongoDB slash NoSQL preferred if you want your data to relate to each other like a graph? Um, both are. I mean, it is something that you can do if you want to graphically represent your data. It's MongoDB is absolutely definitely it's absolutely an option that you could use for that. We've got folks that joined late. You can watch this from the start if you go on twitch.tv/MLH and just scroll all the way to the beginning. You'll be able to see everything. You'll just be on a slight delay at this point. And how did you use Compass? Yeah. So you're going to go to the link that I set up there at the top. And the first thing you're actually going to want to do when you go into Compass, before you do that, as a matter of fact, I'm going to go ahead and get you a link to sign up for MongoDB Atlas. You're going to want to sign up for MongoDB Atlas. That's going to give you the browser version of Compass, essentially. And then once you get there, you're going to sign up for MongoDB Compass. You're going to download it to your computer. It's actually an application that lives directly on your machine. And when you start spinning up databases on your MongoDB Atlas account, you could start using a connection, a URI connection to MongoDB Compass in order to kind of visualize the entire database as you build it out. Okay, cool. So that was our live example. Now we're going to dive into data modeling in MongoDB as I promised. So we've talked about MongoDB's flexible schema design, but you're probably wondering exactly how to model a schema for your application. So that's one of the cool aspects of MongoDB's platform. It truly depends on what you're building. Since document databases are capable of expressing data relationships in more nuanced ways than relational databases, this means that there are various considerations you need to make while you're developing your schema design. And if you want to read more about this, there's actually a really cool article that you can check out on your own. I'm going to drop it in the chat here. Feel free to save it for a little bit and just, yeah, save it for later. And yeah, get back to me if you have any questions. Someone's asking, how did you get Compass? You're going to use that link that's scrolling across the bottom of the screen for you right now, mlh.link with the MongoDB-Compass. And you're going to be able to download it directly to your computer. So it should support everything from Linux, Windows to Mac OS. All right. So I highly recommend asking yourself these questions when you start to model your data. So is your application going to be read or write heavy? Because this is going to influence whether you want to optimize for query performance or for write efficiency. Second, we should understand exactly what data is frequently accessed together. So keep in mind all of the previous slides that I showed you. Which data do you want to live in the same document? Which data can sort of live in a separate document and be referenced as an embedding or as like you know, a reference in a different document. So keep all of that in mind because it's going to basically inform the way that you're designing your database later on. Third, we need to think about our performance requirements. So this will influence various decisions about how you're indexing, sharding, or whether to embed or reference related data. We're going to get into indexing a little bit as well. So if you're not familiar with that term, please don't worry. We're going to get into it. And finally, we need to consider scalability. So how the data is going to grow over time? How is your application going to change over time? And where is that data coming from? Because that's going to influence how we choose to accommodate that growth in the future. So really understanding the end goal prior to modeling your data is going to help you unlock all of MongoDB's benefits, especially since proper schema design is probably the most critical aspect of deploying a scalable, fast, and easy to use database. So as I mentioned before, you're probably going to start modeling your database before you even understand what the idea is for your hackathon project or for the project that you're building on the side. As tempting as that may be, and as easier as that will be if you use MongoDB, it is still very beneficial for you to kind of think about what some of the baseline requirements for your data are going to be prior to you actually building things out. Okay, so MongoDB is cool. What is the trade-off? Honestly, I don't really see a and let me just put this up on screen. I don't really see a trade-off. It really depends on what you're familiar with. If you're not familiar with NoSQL, if you're not familiar with MongoDB, then the trade-off is you're gonna have to, do a little bit of learning. And there are a lot of different learning, like self-serve learning and educational materials that MongoDB currently has on offer that you can go in and actually, get really well versed on some of the features and like all of the different things and functionalities that MongoDB has to offer. So I'm going to get into that a little bit later as well. I'm going to show you how to like earn some skill badges, how to go through MongoDB University and maybe claim your own stuff and like, like put it on LinkedIn or do whatever you want and just show the world that you're like becoming a MongoDB expert. But to me, that's really going to be the only trade off. If you're really, really familiar with traditional databases, then MongoDB is going to have a slight learning curve, but there are many, many resources out there that are going to help sort of flatten out that curve for you. Can you share some learning materials to ingest data slash stream from Mongo to OLAP? Yeah, I mean, we could look into it. I think that's more of a question for Discord for later on. Like I said, this is more of a beginner friendly workshop. And we're also going to be doing vector search on Monday. So if you want to jump into that and kind of like take a look at how things work on that end as well, definitely join on Monday. But today we're just going to be sticking to some of the more basic concepts. So we're just referring back to the slide here. At this point, you seen a lot of differences between relational ways of doing things and MongoDB document way of doing things. But just bear with me because I promise I'm not being super repetitive for no reason. When designing a relational schema, developers will model their schema independent of queries. So this requires normalization or the process of splitting up your data into tables so you don't duplicate data. I know folks are talking about data duplication and repetitiveness earlier. In a relational example, you can see that the user data is split into separate tables so it can be joined together later on using foreign keys by way of the user ID column or of the professions and the cars table. So let's take a look at the MongoDB schema. It works a little bit differently because there really isn't a formal process, algorithms, or truly any hard and fast rules for how you need to structure your schema. It's important to keep in mind that when you're designing your schema, the only thing that matters is that you design one that will work for your specific application. So you can see that instead of having our data in various documents and collections, we are embedding our data into arrays and objects within the user object that's pictured on screen. This allows us to make a simple query to pull all that data together for our application. So I've said the word embedding a couple of times earlier and referencing as well. Now let's quickly go over embedding versus referencing. With MongoDB schema design, you really only have to have two choices with every piece of data. You can either embed your data directly or you can reference other pieces of data using the $ lookup operator, as I mentioned before. So referencing is really similar to the join operator in SQL. Think of it as exactly that with a little bit of nuance. It allows you to split up the data to make more efficient and scalable queries while maintaining the relationships between all of your data. So there are a handful of advantages and limitations for each choice. For embedding, some of the advantages are you can retrieve all relevant information in a single query. You can avoid implementing joins in application code or by using $lookup. And it's also possible to update related information as a single atomic operation. So keep in mind, by default, all CRUD or create, read, update, delete operations on a single document are ACID compliant. And I've talked about ACID before. Please look it up if you are unfamiliar with acid or acidity in terms or atomicity in terms of databases, because those are really just like fundamental aspects of database building in the first place. But I digress. If you need to, if you need a transaction across multiple operations, you can also use the transaction operator. So definitely do not be too overly reliant on them in your application. Increase the query performance by limiting the size of documents that you're sending over. So right now, I think the size limit is going to be 16 megabytes. So if you're embedding too much data inside of a single document, you can potentially hit this limit. So you want to keep things as distributed as possible to avoid, especially if you're storing things like music and videos. Those big blobs of data are going to be really, I guess, like space intensive or storage intensive. So on the other hand, the advantages for referencing are the smaller documents because you're splitting up data. So this means you're less likely to reach that 16 megabyte per document limit. And infrequently accessed information is not needed on every single query. So you're not taking in useless information to a query that doesn't require it. And actually, you can reduce the amount of duplication of data as well. There you go. So we've got folks that are going in and giving us the goods: atomicity, consistency, isolation, and durability. And all of that basically has to do with how performant your database is, whether or not you are doing I guess transactions on a one-to-one basis, whether or not your current inventory is showing exactly what's there after a transaction has taken place, whether or not it's going to be durable, meaning like, let's say there's a power outage, does your database persist after that? And I think consistency and isolation I kind of like touched on as well, but y'all could get the full rundown through Google if you like. It's probably going to be a lot better in terms of explaining than I can. All right, so the limitation for referencing is that in order to retrieve all the data in the reference documents, a minimum of 2 queries or $ lookup is required to retrieve all the information. And yeah, I mean, that's pretty much it. I think we all have a pretty solid grasp of the ways to split up and access data while designing your MongoDB schemas. So let's go over some of the common relationships, and then I'll also have some like live examples of what these common relationships would look like inside of a database. So the first one is one-to-one. User document is a great example because it has one-to-one data inside of it. If in our system, a user can only have one name, then we can model all one-to-one data as a key value pair in our database. So another example is if an employee can only work in one and only one department, this is a good example of just like having one-to-one data. The next is one to few. So let's say for each user, we need to store several addresses. Even if someone moves a ton, it's unlikely that they would have more than a couple of addresses, right? So for these relationships, they are categorized as one to few. So for one to few, embedding is preferred. As you can see here, the actual addresses are listed out inside of this nested object within the addresses array. And the next one is going to be one to many. So say, for example, you're building a product page for an e-commerce website. In the system, you're saving a lot of information about all the many parts that make up each product for repair services. So with a schema that could be saving thousands of subparts, like, or tiny parts that go into a particular product, we don't need to have all of the data for the parts in every single request. So this will just waste a ton of resources. It'll bloat your data. It might take you over that 16 megabyte limit that we mentioned earlier. So in order to kind of compress the data that you're putting into a single document, you can simply reference it here. So as you can see, instead of listing out all of the different parts, like it's not like I referenced the addresses earlier before, it's not the entire address that's listed. Object IDs, especially from the front end, because that ID is going to be available to you. But and then like the details can follow thereafter, but you don't necessarily need to store all of the different data that is related to each of those specific parts within the product document. And here you can see the product object ID AAA. You know, it's not making this original product document super bloated. And next we have many to many. So for the last schema design pattern that we're going to cover, let's pretend we're building a task application. So in our app, a user will have many tasks, and a task may have many users assigned to it. So in order to keep the relationships between users and tasks, we need to have references from one user to the many tasks and references from the one task to the many users. So for the example on this slide, you can see that each user has a subarray of linked tasks, and it's going to be the same thing essentially as the previous one, but this time each task has many users, and each user has many tasks assigned to it, and it's referencing only the object ID. So if we were to only embed that information, like I said, we would definitely go over that data limit, and it would make the database a little bit slower. Like I said, there's a ton of different ways to express your schema design, especially ways just beyond normalizing your data like you would in a typical relational database. But just keep in mind that this is just the beginning of data modeling with MongoDB. If you're intrigued, we have a ton of resources available, and I'm going to kind of get into those a little bit later. I'm just doing a quick time check here and some of the questions. Awesome. Let's jump back into the example, and I am going to kind of show y'all the differences between some of the relationships that we had. So here, this is going to be a good idea, a good example of one-to-one. Obviously, the name and everything here and the password, this is going to be a one-to-one relationship. If you look at playlists, this is going to be a one-to-many relationship. I kind of got into this before, but as you can see, it's only referencing the object ID within this playlist. It's not actually referencing the entire song. And then the songs here, you can, I mean, we'll probably be able to get an idea of which songs are which, but you're going to see that there are, like, you know, a ton of different relationships that are actually listed here. So the embeddings, obviously, that's for the Gen AI feature of the actual project. But as you can see here, these are what's actually represented in the playlist document. And then you have the artists, obviously. So for each artist, you're going to have top songs that are also referencing that. So that's going to be one to many as well. I'm not sure if there's a one to few example in here, but you get the idea. It, like I said, the data can be modeled in many different ways. And if you want to keep playing with that application, definitely do so, because I think it'll, you know, kind of help you to get a little bit hands-on. What's the difference between one to few and one to many? So let's jump back into it here. I think this is slide 18. So this is one to few. So one to few is, as you can see, this one user, Joe Carlson, has two different addresses. But instead of referencing the address as an object ID, it's actually embedding that address directly into his user document. So it's not just referencing an object ID. The actual information lives there. Whereas in one to many, it could be the same thing, but instead of actually listing out all of the information for each individual part, it's only referencing the object ID. And as I mentioned before, this is so that you're not actually bloating your data, so that you're not actually, yeah, and that's the other difference, sorry. One to few uses embedding, whereas one to many uses referencing. So this is referencing, you're referencing the object ID, whereas here you're embedding the actual street address into the document. All right, someone's asking, how can we reach the analyzing part of the database? So that's just going to be a tool that you can use and make your own connections when you build out your own databases. Unfortunately, I only have a read option for my URI connection that was provided by a member of the MongoDB team. Shout out to Pavel. Unfortunately, I can't. I'm not allowed to actually share that with y'all publicly. But if you want, you know, we can set up some sort of database and walk you through it. If you hit me up on Discord, I'm happy to kind of like walk you through the process and show you how to connect that database to MongoDB Compass after you've set it up in Atlas. All right. So we are actually running out of time. There was a lot of stuff I wanted to get to. I think we kind of ate up a lot of time here in terms of the demos. I was unsure of the timing here, but I do want to talk to you a little bit about aggregation framework. So sometimes you want to do more than just the basic CRUD operations, which is, once again, create, read, update, and delete. You might want to run your calculations, or you want to analyze and transform your data. So this is where the aggregation framework comes in. This is going to be really interesting for the folks that want to be able to have some sort of like programmatic or dynamic way of accessing and you know, inputting data into their database that is going to basically make things more performant as your application grows. So this basically refers to a flow of operations that processes, transforms, and returns the results. In a pipeline, successive operations are informed by the previous result. And we're just going to see how that works. Just think of it as a pipeline with different types of functionality. As your data goes through that pipeline, it basically transforms into the way that you want the end result to look like. First things first, let's review the typical syntax for a query in MongoDB. We'll always use a driver or a library to connect to MongoDB and then query a database. This way, we write our code in a language of choice and send and receive objects directly in our program. So if you're using Python or JavaScript, this is where it would come in. The next, basically, it's going to go from the database or keyword to the collection name. The next is going to see the operator or the command. The next, you're going to do the query or the filter. So this is like where your data, is actually being filtered down or basically being formatted to fit the query that you want. And then the options in the settings. And then finally, from there, you're going to see that this turns your information. Like basically, this is how you would query your API syntax structure so that you would find all of the information that you need here. This is the exact thing that you would need for all of the data that's currently being displayed. So let's start off with create, how to insert data into the database. I'm going to show you how MongoDB shell syntax in this slide. So if you're not familiar with like any of the MongoDB shell, it's just a command line experience you can use to work with your database. Mongo also provides libraries for each of the major programming languages. There's a ton of SDKs, like I said before, Python, JavaScript, Node.js, Java, C, and Go. So let's take a look at one way to insert data. So you can use the insert one command. This is going to be basically inherent to a lot of the programming languages that you use. I can kind of dive into some of the GitHub repo if we have a chance and show you how some of this insert functionality works. But here we're inserting Jane Austen into the database. So the DB, that's going to be obviously the collection, and it's going to have the authors, the DB is going to be the database. The author is going to be the collection. And then this is going to be the command. You're going to insert the one command, and it's going to be insert the name Jane Austen. These are the books that you're going to insert, and then the aliases of Jane Austen as you're actually inserting that into the database. So the other one is read. So basically, in order to retrieve data from the database, the syntax will feel very similar to the command we just looked at. So right now, you're in the current database. Then this is the collection, it's named authors. Then next, you're going to find all the documents that match the query. There's also a find one command if you only want to retrieve one document. And then next, we're going to pass the query to the find method. And in this case, we're querying for documents where the name field is set to Jane Austen. Next, we have update. So once again, we're in the current database. In the collection of authors, we're going to update one document. Once again, there's also an update many if you want to do this across like a large scale of documents that you're trying to update. And then here is going to be the filter. In this case, I'm just searching for documents where the name is set to Jane Austen with an I, because that's the incorrect spelling, obviously. And then the second param is going to be modifications you apply to that so that you can just basically like have it in a document or a pipeline. You could just like have this in your aggregation pipeline where you're automatically correcting everything with Jane Austen with an I to Jane Austen with an E. And then finally, you have delete. And it's very similar in syntax. Once again, you have the database, you have the collection, you're going to delete one document. You could also delete many. And then the only required parameter here is that we're going to delete the stuff that has the name Jane Austen that's misspelled. And yeah, that's pretty much it. That's CRUD. And then you're going to jump into multi-stage aggregation pipelines. An aggregation pipeline basically consists of one or more stages that process documents. So the entire output of one stage forms the entire input of the next stage. So some people like to compare the aggregation pipeline to the Linux pipe, where the output of one tool becomes the input of another. But here, obviously, you can create multi-stage pipelines on a collection that do things like filter for the documents or match the documents in this case. And you could also join documents if you'd like. And this way, like, you're using $ lookup, as I mentioned before, which is the MongoDB equivalent of joining. You could also group documents together. And basically, all of this is happening in a form of a pipeline. And then finally, you can run a calculation like average and then sort the results. So this is what an aggregation pipeline looks like if you wanted to kind of visualize it. And we're just going to kind of get into how some of that aggregation pipeline would look like. Hello there. What are you teaching? We're teaching stuff about MongoDB, and I am desperately running out of time. So hopefully we get to the end of this section here. To run an aggregation pipeline, you build an array with all of the steps, and then we can call all of those step stages. And then you just run it using an aggregate method. You will do this using your programming language of choice and sending the pipeline to the server to be executed. So this is sort of an example of what that would look like if you wanted to have this aggregation pipeline basically done within your code base. This is how it would look like inside of MongoMP. We had this example here inside of the search feature. This is also an aggregate pipeline. So basically what it's doing is it's looking for anything that has the text within the search query. It's going to look for these paths, and then it's going to filter down to the project to this object here that I'm scrolling over. So that's kind of what the aggregation pipeline looks like in real life. And yeah, I mean, that's pretty much it. We are getting close to time. I'm going to, sorry for too many questions. No, it's fine. I think I overestimated the amount of time we had. We did get started a little bit late, so I'm going to do a little bit of runoff here just so we can get to the end of this section. But basically, we're just going to look at the simple pipelines that we could do. So we've talked about dollar match or dollar lookup. Dollar match is a filter stage that lets documents pass onto the next stage if they match certain conditions. So here, documents with 100 pages can go on to the next stage, can use various operations such as $GT, $LT, and you could look at the documentation for MongoDB to kind of get a better idea of how those operators look like and how they work. So you might be thinking you don't really need to use an aggregation pipeline if you're doing all this matching on the number of pages, but you know, I like I said, if you like to do things programmatically, this just makes things a lot simpler. So the dollar project passes along the documents with the specified fields to the next stage in the pipeline. The specified fields could then be put into existing fields from the input documents or newly computed fields. So in this example, documents in the books collection have a ton of fields. After this project, they will only have the title and the cover field. So basically just like filtering down to a more condensed version of your object. The dollar limit sign is pretty simple. You're just going to limit or clamp or reduce or clamp the number of documents going to the next stage. So in this example, only 5 documents are going to go into the next stage. And once again, I want y'all to look at this from the aggregation pipeline perspective. These are all steps that are going towards you getting down to a specific query or a specific type of data that you want to display either on the front end of your application or to the end user, whatever have you. And then finally, MongoDB documents can also contain arrays, which is different to some other databases and can feel a little tricky. So I'm just going to walk you through 3 quick examples here. These are arrays of strings, obviously, and you know, they're all basically incorporating all of the different genres that you can have within a specific book. These are all books within this collection. So if you want to query for an exact array that contains one particular element, here we can use the $match, listing all of the elements that need to be included. So here, anything with epic is going to be filtered down to, so these 2. And then if you want to find books that have fiction and fantasy, you're going to use the aggregate that include all. So it's $all, and it's going to include anything that has fantasy and fiction. And it looks like it's going to filter down to these 2. And then finally, if you want to find books that have an epic or fantasy, you're going to use the $match. And basically, it's going to filter down to the ones that only have fantasy and fiction or fiction. Let's see. And in order to find Dune, we need to compare the whole array. So this $match will find that document. So here you're going to do sci-fi, space, and epic. So only get the ones that have exactly those 3 things in the array. And it's going to filter down to the Dune book. And if we don't provide the exact array, it will fail. So here you have space and epic, and this is a $match. So it needs to match exactly. No results come up. And that is pretty much it for the time we have today. I'm going to be sharing the slides, and y'all could kind of like jump ahead to like, some of the slides that I wasn't able to really cover. Some of the things that I do want to show you here. We did talk about MongoDB Compass. So MongoDB Compass is just a graphical user interface, and it's great for if you're more of a visual learner. I kind of showed that to you earlier. Like if it's definitely something that I think would be beneficial for folks that want to kind of take a look at what the actual database format looks like. And then from here, we also have the MongoDB AI chatbot. So this is just a little helper. It lives on the MongoDB documentation page and is trained on all of the MongoDB documentation. So if you need help creating an aggregation pipeline, I highly recommend using this for some quick answers. And then finally, we have the MongoDB developer platform. I just want to let y'all know that MongoDB is more than just a database. It's an entire developer platform for you. The cool part is when you join, basically the fact that it's intuitive and the fact that it can accelerate your pace of innovation. You can also access a ton of platform capabilities through a single API. It has a support for transactional processing. You can incorporate MongoDB's various tools and features into your applications and not only advance them, but encourage them to be competitive at your next hackathon. So you could deploy a bunch of different stuff across 3 major cloud providers, regardless of what you're currently using. But yeah, I mean, that's about it. I'm sorry that we didn't get through all the content. It was a lot. It was actually a lot less than my previous workshop. I tried to condense it as much as possible. But if you have any questions, please reach out to me on Discord. I have taken up way too much of your time. I'm 3 minutes over. I'm just going to go through the comment section one last time. Thank you so much. I appreciate that you enjoyed the workshop. Can we get the slides? Yes. So go to discord.mlh.io. Join us at Global Hack Week. Go to the Ask MongoDB channel, and I will be posting the slides there. And there's also you'll also probably see the slides from the previous session that I've done. And yeah, I'll see you again on Monday. Please make sure you check out Global Hack Week Beginners Week. There's going to be a ton of challenges here. One of the challenges is going to be you actually going in and getting your GitHub Student Developer Pack, but also your MongoDB Student Skills Badge. If you click in here, you're going to be taken to a different platform that basically walks you through how you can get that skills badge, and it's going to incorporate a lot of the information that we learned today. So yeah, make sure you check it out. I've already claimed this badge. I'm not sure why it's telling me it's only 50% complete, but it's 10 questions. It's a knowledge check. If you want to bone up on some of the information that we did cover today, like document model, the database fundamentals, and distributed database architecture, definitely feel free to check that out. It's only 10 questions. It shouldn't take you the entire hour to complete the knowledge check. But definitely share it on LinkedIn once you do have it, because we want to see what y'all are doing. So yeah, I mean, that's pretty much it. I'm going to let the next presenter get online because I know they are rearing to go. But really love y'all. Definitely check out Global Hack Week and continue to stay locked in because we have way more programming for you. Yes, 1 hour time limit, and I'm out of here. Hope y'all enjoyed.